All right, in this video, we're going to be looking to see how we can come up with an equation by looking at a graph. Now, when you look at the instructions it says write the equation of the sinusoidal as either a sine or a cosine. So first off, a sinusoidal function is just a function that follows this shape of the graph, where it's continuous, where it repeats itself, it's periodic, it keeps repeating itself over and over and over again in both directions. And so if that follows that shape of that sine wave, we would say that it's sinusoidal. And so technically, we could come up with a number of different equations. We could do either sine or cosine for those equations. And so what I would recommend doing is just looking at the graph and just seeing what pops out to you. Like when I look at this, I see this shape, which is based on the cosine function. So that's what we're going to do. We're going to base this on the cosine function. Now you might say, well, how can you see anything different? Well, let's first do this. So one of the first things you're going to want to do is, after you identify what part of the graph you're going to focus on, is figure out where the midline is. Now remember, the cosine function looks like this, and it has a midline right here, where the graph fluctuates above and below that line. Now that line can move with the graph. So when the graph moves vertically up and down, that line would move with it. So when I look at this graph, I see that that midline is right here. Now another way to figure that out is we could take from the highest point to the lowest point and count how many units that would be. So here that's a total of 6 units. Half of 6 is 3. So then that midline would be right smack dab in the middle of that. So 3 units either above or below the highest and lowest point. All right, so now let's go back to what I was saying earlier about looking for, well, how could you see any other graph? Well, when I look at this graph now, when I put this on here, I see this, which is the sine function that's been flipped vertically. So that would be another alternative. I could do that for the graph. I could, if I saw more of this graph, I could say that I see the sine function right here, and I could base my equation based on that part of the graph. Or I could look at it and see that this would be the sine function over here and base it on that part of the graph. So there's a lot of different options, as you can see, and all of them are correct. So when you're doing this, if there's a question like this on the test, I would look at your equation and see, can you get the graph from the equation that you created? So how do we work our way backwards? So once we identified part of the graph that we're going to focus on, and we have that horizontal line, now we're going to start to find some of those pieces. So what pieces am I talking about? Well, since we're dealing with the cosine function, remember this is the general form of the cosine function. So my goal is to find those 4 pieces and then plug them into the equation. Now some of these are going to be easier to find than others. So let's start with the A value. The A value is probably one of the easiest, especially once you have that horizontal line sketched there. So the A value is the distance between the highest point and that midline. So that distance is 3 units. So that's our A value is 3. I'm going to skip the B value for right now, and you'll see why in just a second. But the H value, let's talk about that one. Now remember, this is based on the cosine function. The cosine function, when you're looking at that first interval, starts at 0, or starts on the y-axis there. And this point is still on the y-axis. So it has not been moved horizontally at all. So the H value will just be 0. My value for K is how far up or down it's been moved. So now again, it was here, the midline was here on the x-axis. Well, it's been moved down now a total of 1, 2, 3, 4 units. So it's been moved down 4. So we're going to say the K value is -4. All right, now let's talk about that B value. Now first off, remember for the B value, is 2 pi. So to find the period, that's what we were doing in the previous video, we would take the B value from the equation and take 2 pi divided by the B value and give us the period. Now these two are interchangeable, because if I wanted to, I could solve for B by multiplying B on both sides and then dividing by the period. So in other words, B is also 2 pi divided by the period. Oops. So that's what we're going to be using for this. So to find the B value here, I'm going to look to figure out what's the period of the function. To find the period of the function, we're going to take any 2 points on the graph. Now, let me rephrase that. We're going to pick a point on the graph and figure out another point where it would repeat itself. So for example, this point here that I highlighted in purple gets repeated again right here. And so now I want to figure out what's the horizontal distance between those two. So to figure that out, I would take the x values and subtract them. So 4 pi minus 0 is just 4 pi. So the period in this case would be 4 pi. And when I simplify that, the pi's cancel out, and that reduces to 1/2. So now I have everything that I need. I have my a value, I have my h value, my k value, and my value for b. So now we're going to plug those into the equation. So my specific equation now, based on this part of the graph, would be y equals my a value, which is 3, times a cosine of my b value, which is 1/2, and then it'd be x minus 0, which is just x. And then plus k, so plus -4, or just write down -4. And there's your answer. So that's really all there is to it. So the hardest part is when you deal with ones like this one, for example. So this is one where, again, you could do the cosine function. You could do the sine function over here, or you could even do the sine function here that's a vertical flip. So there's a lot of different options that you could do here. Now, even if you were focusing on that part of the graph, it doesn't matter which points we use as long as it's represents the repeated points to find the period. So if I'm trying to find the period here, I could pick these 2 points and find the distance between those two by subtracting pi over 2 minus pi over 6. Or it might be easier to even use these two, because these two repeat themselves. And so that would be taking 5 pi over 6 minus pi over 6. And you'd get the same answer. So that's why it doesn't matter. So, or we could use these 2 points and find the distance between those. So all I'm getting at is when you're trying to find what the period of the function is, pick a point and then find when it repeats itself, subtract the x values, and that would give you the length of the period. And again, you use that to find the b value. So the b value is always, for these problems, is going to be the 2 pi divided by whatever the period is. All right, so good luck now as you work on the rest of that sheet.